Good afternoon. Unit 4 of your syllabus. Unit 4 of your syllabus completely uh, discussing about a value stream mapping only. That is how to draw value stream mapping. Okay, I already explained you, uh, but still I want to say some few points here. That is how to value stream map. How do you create a current value stream map? It's very essential to first of all you should draw the current state map. Then you can draw future state. So I will explain you here how to create a CSM, that is a current state value stream mapping. How do you create value stream map? Okay, it's very important here. It's a team exercise. One can't do. It's not an individual task one should do. It's a team exercise. It involves people that are involved in the process. What actually happens, not what should happen. See, remember here, what actually happens, not what should happen. So you are going to draw the existing current one. Usually supplier to customer for a specific product or product family. So you are going to draw value stream map for usually for a supplier to a customer. For a specific product, you have to choose one product. When you draw value stream mapping, you should say that this value stream mapping is for this part family or for this particular product. Okay. Say, for example, if you take any of the components, say a crankcase for an assembly component of a tractor or a jeep or anything like this. Okay. If you take one product, you have to draw value stream map only for a particular product. Choosing the product or product family. Okay, how are you going to choose a product? You are wish to draw a value stream map. How are you going to choose a part family or product family? You need to choose one product or family of a product to map. Okay, but choose one product family or a product. Select one to be mapped. Okay, so where if you feel that there is a need to improve, needs improvement, valuable to the company. Okay, when you take a product, it should be a key product. Okay, because any improvement you want to show should be shown to a key product. So, and also there is a scope for improvement, needs improvement, and of course you need to there is scope improvement and valuable to the company and high likelihood of success. Okay, yeah, it's very important. While choosing the product, you should make sure that the high likelihood of success and can form the base for improvement to for other. Okay, if you take a product, so that product should be the basis for improvement of improvement for some other product or a family of products. Okay, so these points very important when you're going to choose the product. Needs improvement, valuable to the company, and high likelihood of success can form the basis of improvement for other product or families. Next, product family analysis. How are you going to analyze? Sometimes a company has many products and it can be difficult to decide which map or define families of product. Okay, so certainly when they're going to have multiple number of product, company also get confused at which product they're supposed to choose for value stream mapping. Product families share common process and process routes. Simple matters can be used to identify product family. Use your highest volume or contributing product. Certainly when you're going to choose the product, we should give more contribution for the company in terms of profit. Or we can say the highest volume of manufacturing. So that product can be chosen for value stream mapping. Okay. Identify suitable product family by grouping. Okay, so you can go for even grouping. Okay, it's a group products into families based upon similar downstream steps. So when you're going to have multiple number of similar product, you can make a product family. So you're going to have a similar process. Okay, likewise you can group. Okay, ABC can be one group, and the DEF one group, and the GHI can be one group. where do we start? Now you have chosen a product family or a particular product you have chosen for drawing value stream mapping. You feel that there's improvement can be done for that product. Then how do we start now? Take one A3 paper or a drawing sheet typically and pencil and inquiring set of minds. Okay, it's very important. I told that it's a teamwork. You should take the people having the inquiring set of minds, a common thought of people. Define the process to be mapped. Define the process to be mapped and bound the process. Okay, now you have to take the product process map, that is a supplier or a customer. Create a process box for each process step. So you have to create a process box for each process. Okay, when the product is undergoing so many process, converting from raw material to end product, it undergoes so much of different process. So you have to define the process to be mapped and bound the process. You have to create a process box for each. I'll let you know how you're going to create the process box. Sometimes we may map an entire supply chain and the process box can companies. Okay, it also sometimes can be drawn a single map for entire supply chain from customer to the end product. Sorry, from supplier to the customer. Okay, now map the process flow. Already explained in one of the lecture about various icons to be used for drawing the value stream mapping. I think while explaining the tools in element manufacturing, one of the tools is value stream mapping, where already I have explained you various icons to be used for drawing the value stream mapping. So keeping in mind those icons, so I do not explain once again here what these are specifying or signifying. So you take all these icons for drawing the value stream maps. This is what called as the process box for each. Okay, say for example you have ignition, oven, washer, circuit boarding, testing, final assembly, final test request. You're going to have so many process ultimately going shipping. So we can say that each are going to constitute one process box. So we have here supplier and weekly supply you are showing is in truck and undergoing all so many process, and you have here daily production and then directly supplying to customer. Say for example, they say customer 360 components are supplied per day to the end customer. Okay, so this also I explained you in the during that explaining tools in lean manufacturing, information flow and all. One of the things that differentiates value stream mapping from other techniques is adding the flow of information. So normally, in many times we are not going to show the information. Only we are going to show the movement of components or items or things are moving. But here, one of the important thing of value stream mapping is also going to show the information flow. Add information flows to show how orders are placed and schedules communicated. Okay, so it should also show that how orders are going to be placed and how that schedules are going to be communicated across the system. So you can see this one here, how the information is going to flow. That is, you have a production control, PPC department or ERP system, okay, and you have weekly schedule and the monthly forecast supply to the supplier and weekly orders given to suppliers, supply weekly, undergo so much of processes. Then daily schedule is implemented to that shipping, and then they're going to do daily, and here daily order after supplying to customer goes back to the ERP system and all. So they're going to forecast based upon the supplied along with the ERP system and all. So you can say that how information is going to flow from production control, that is from supplier to the end customer. Collect the process data. Next, we need to record the process data for our process. A typical data that should be collected. What data you are supposed to collect is, that is inventory, cycle time, time taken to make one product. Okay, cycle time is very important. Lead time, cycle time, takt time, all things to be known to you in advance for drawing value stream mapping. So cycle time, time taken to make one product, and changeover time from last good piece to next changeover time. Okay, so when suddenly going to happen when you're going to change the product. Okay, changeover time, uptime, the on-demand machine utilization, uptime, downtime, uptime basically utilization of the machines. Downtime, your machine is unable not go into use. So uptime and downtime. Number of operators is very important. Number of shifts, number of operators also very important here. Net available working time also very important because when you go to calculate the total cycle time for a product, you should also know about the net available working time. Scrap rate also important to know the productivity and scrap rate and pack size, okay, and pallet size also important. These data need to be collected. It is a process data. Inventory, cycle time, changeover time, uptime, number of operators, net available working time, scrap rate, pack size. Okay, now you have to add the data here. Remember here, you're going to show all these things here. It is cycle time, changeover time, uptime, and how much they utilized. Okay, it is 90%, 100%, and all. Those things should be shown for each process. It is ignition, oven, washer, circuit boarding, testing, assembly, and you have to show all the process data. And also show the inventory here. Okay, how much inventory lying at this one, 18, 16 inventory is there now. Okay, you can see all those things. So now creating a timeline. We want to show how long inventory remains in the system, how long a product is processed for. Okay, so now you have to create a timeline, how long that inventory is going to stay in each workstation or process unit and all, and how long a product is processed for. Use inventory and daily demand to calculate how many days of inventory you have. Okay, because if you want to forecast, if you want to order, next you should know that daily demand and how many days you have, or days of inventory you have at on hand now. Processing time is taken to process one item, not in a batch, because to order for next item, you should know that the processing time should take into a process of one item, not for a batch, because it may go to vary from batch to batch. Okay, now analyze data. So you can see here, so we have added here an additional the processing time also. That's 60 seconds, 120 seconds, 60 seconds, and all those things. Okay, so at the end you can say that total lead time is 8 days, and total processing time is 8 minutes. Okay, you can see that item. So this is how I explain how we are going to draw velocity mapping item by item. What does our VSM tell us? The timeline tells us that the product takes only 8 minutes to be processed, but a single piece of inventory can be within the organization for over 8 days. Okay, you can see that previous velocity mapping drawn. The data boxes show us which processes have long changeovers or poor quality performance and other issues. Okay, next stage for velocity mapping is to create ideal state velocity map. Now you have that current state mapping, that is actual time taken for cycle time and all that shown here in the CSM, current state velocity mapping. Now we have to create an ideal velocity map. This should be a challenging improvement on where we are today, because it's a challenging one. So if you want to show improvement, you should have the clear idea about where you can show improvement. Okay, those things are very essential here. That's why I can say it's a challenging improvement on where we are today. Future state map, it is FSM. FSM can then be created to move us toward the ideal using a Kaizen improvement bus. Okay, suppose this FSM going to be the continuous improvement. You can say it's an ideal state velocity map, because this is what you thought, this is what you want to reduce, trying to reduce. So it's an ideal velocity map. Moving from current state map to ideal state mapping. So you have here, so many current state maps are there you have, and through a series of future state maps utilizing Kaizen bursts, we move from current state map to ideal state map. Okay, remember here, so you are identifying so many areas where you can improve. Okay, maybe a cycle time or other time node here, processing time and all, you are finding that these are the areas where you can show improvement. Ultimately, then you are going to draw the ideal state map, nothing but a future state map. You can say here at the end you are going to draw ideal state mapping, indicating that the time taken at the end. Okay. Okay, that's how we can set the velocity mapping. So unless you draw on your own by studying some actual industrial problems, this is going to be only okay, some sort of okay, we are explaining about how to draw velocity mapping and only. Okay. So when you're going to draw actual, that is, take a project or go to some industry, take some actual problems, draw value stream mapping for their product, and then show some improvement or such some improvement, then that's the realistic view of value stream mapping. So unit 4 is totally focusing on value stream mapping only. So even for exam purpose also, you should have that all the icons to be drawn also should know. Then how we are going to draw that value stream mapping by showing all various times also, number of shifts also, number of operators, and changeover time, cycle time, those things how we are showing using the process data, those to be shown, and also how improvement can be shown by identifying the an area where we can show the improvement. So unless you do some actual figures, so it is one, you won't get any idea. So take one or two case studies of a company, actual case studies, and draw value stream map. You'll understand the how this is going to work also, and also you can show some improvement. You will really enjoy because it's a teamwork where 2-3 persons can sit together, draw everything on a drawing sheet or A3 size paper, and write down the existing system and also identify the core areas where you can improve and draw one more ideal value stream mapping or future state mapping, and then you can really find that how much improvement can be done in terms of percentage of this thing. Okay, it's a good tool in remanufacturing. So all can think of doing one actual problem instead of going on. It's only I told you about how to draw and all. Okay, you should take one a real case study, then you understand it. You will take next one.